Hello, everyone. Welcome to the first course of our coding class. I'm Daniel Chen, and I'm going to be your teacher for the next 8 classes. Do you guys want to introduce yourselves, or hold on? Sorry, just all right. Hello. Does anyone want to introduce themselves? Okay, so in this class, what we're going to do is we're going to focus on helping you guys be able to kind of code your own programs, whether it be like coding your own short game or coding a simple like password protection program. And I also want to be able to teach you guys how to continue to learn and grow by yourselves so that way you can continue to improve your coding skills if you wanted to outside of this class itself, so that we aren't dependent on simply whatever you learn in class. After all, one of the most important lessons you learn in programming classes is that everything is already kind of pre-made for you. The programming languages themselves have already been invented, so it's just up to you on how you want to use them, how you want to structure them. And there are many other people who are also programming. They've often already encountered some problems you may also encounter, and so you can always use Google for help. It's it's almost like a mantra, like a motto in the coding community at this point, or Stack Overflow, which is a common website to ask program questions on, is almost like most people's like mini teacher. All right. So for this class in particular, what I wanted to do for today is I'm going to show you guys a few of my programs to kind of show you guys what we can kind of look forward to at the end of this class. And then we'll introduce the first basics, or introduce the first basic level of code and like all the knowledge you need to actually begin programming. This specifically includes knowledge that technically isn't directly related to the act of typing words and having them do something, but it's still really valuable to know so you can actually understand what the code is going on. All right. So there are a few people that just came in, so I'm going to kind of summarize everything I said real quickly. Also, if I'm talking too fast, you can message me and I'll try to slow down a bit. So essentially to summarize, today we're going to look at a few pre-made programs to kind of see like what they look like and kind of how they work, and to see what you can try to make at the end of the classes. And they're going to introduce the basics of coding, specifically knowledge related to programming. And then at the end of the class, we'll do some basic programming. All right. Firstly, I want to check with everyone. Does everyone have an IDE installed on their computer? In the WeChat group, I recommended the IntelliJ community version IDE, which I personally use. I think it's pretty reliable. But if you have a different version, that should work as well. It'll just probably have a different like autocorrect than the one we use. If anyone doesn't like have one installed, then please message me now. It would be pretty bad if you didn't, because you need it to actually write the code in. You can't just write it in like a random Google Doc. It has to be in a specific integrated development environment, which is what IDE stands for. It has to be in a specific area so you can actually type it and the computer will recognize, oh, you're typing code. So everyone has it, right? No one is missing any?
Could you please specify what kind of program it is?
So we're going to be making programs, but the program you use to program in is called an IDE. There are many different types of IDEs you can get. A lot of them are free. The one I personally recommend is IntelliJ, the IntelliJ community version. I'll send you a link if you need it.
Okay, I think I have it. Is it like IDEA?
Yeah, their version, the name of it is IDEA.
Yeah. Okay, I have it.
Yeah, so that's what we're actually going to be using the coding. So let me actually show you what it should look like. Okay. So this is the stuff I've already made so far. Firstly, I'm going to walk you guys through to how to use it first. So that way I can use this as examples to talk about everything else. So can everyone open their program real quick? And then if you need to set it up, the first time you like run it, you'll probably need to like set up some stuff where basically just ask where to download stuff or where to open. But if you've already done that, then what it should give you, Let's see, there's. Yeah. So the first time you run it, it'll ask you to create a new project, which should look something like this. You don't really need to worry about any specifications, just essentially you just keep clicking next since the defaults are already working. And then when you want to put a name, you can put whatever you want for it. And then it'll create, and the new project should look something like this. Does everyone like have it set up? Do you guys need any help with that?
It says there's no SDK specified.
Could you, do you want me to show you can you show me your screen real quick?
Okay. Does it looks like it's like this?
Can you go back a bit? Just click no and click cancel real quick. You went to some click cancel. All right, yeah. Okay, go back to new project again. And actually, yeah, you can click on like the little drop down menu if you want, but it's just a little optional thing. You don't like really need it. You can just click create and it should be fine. Yeah, just ignore and go ahead. Ta-da. Yes, K is mostly optional. All right, so I'm gonna share my screen again. Okay, so the first few things we're gonna talk about in Java are kind of more concept.
Code, I'm clicking create, but it's not creating at all.
All right. Okay, so real quick. Yeah.
So I get this the SDK specified, but when I click no, it doesn't allow me to make it.
Does it work on the iMac?
I don't know anyone who uses a Mac, so I don't know. I've never run into that. Like I don't.
On Windows, and it's just not letting me create it.
Huh?
It's just not letting me create it.
Can you share your screen real quick?
So when I click create and then hit no, it just won't create.
Just click yes. Well, yeah, because it says, do you want to create it without an SDK? Just create it for now.
Okay.
So just create it without the SDK. It's fine.
Okay.
Also, you'll have to test it for the Mac. Those of you who are using the iMac, we won't be coding too much for first class, so it's going to be fine. But you might have to go and find another IDE that works on Mac. You could try Notepad, I think. If it works on Mac, I don't really know what to do with Macs. It's definitely not something you've actually done. But for right now, we're just gonna be doing concepts and stuff. So you guys should be fine. And I'll talk to you guys like over the weekend stuff to see if we can figure out something for those specific computers. All right. But yeah, okay. So now that we set up the project, you can close it for now. I just wanted to make sure everyone was capable of making it before we actually did anything. Yeah, I just want to make sure everyone's capable of creating the project before we actually get started on anything. All right. But right now you might want to take out like a notebook or something, because now we're actually going to talk about programming. So firstly, the programming language we're learning about, Java, is, as I'm sure guessed, is different from all the other programming languages. It has its own special like gimmicks, its own advantages, its own disadvantages. Right now we're learning Java because not only is it one of the more common languages in the world, up there with C languages and Python, but it also strikes, what I like to think is like a good balance between the advantages and disadvantages of Python and C. Python in general tends to be pretty slow, but also extremely user-friendly, while C tends to be harder to read, especially if you're not training it, but it works extremely quickly. Java kind of strikes this mid-ground between being able to read the code and quickly understand what it does, while still being maintain a relative, pretty fast speed relative to other programming languages. Java also has various other features that make it extremely useful and just really convenient. The three most important ones that I want you guys to know is that it's an object-oriented programming. It has its own implemented garbage collector, and it's platform independent. Specifically, let me open all right, so specifically, object-oriented programming means programming that is centered around data rather than functions. Essentially, Java is built around being able to build functions around data rather than trying to manipulate data to fit functions. And Java is one of the languages that works in this manner. So essentially, OOP is the shorthand for it, and it's called object-oriented programming. And as you can guess, objects are pretty much the focus. In Java, it's what we use to store data and information. There are different storage types for integers or words or for characters. But right now, all you really need to know is that Java is focused on essentially storing and manipulating data through its use of objects, which are essentially just kind of buckets or containers. The second concept that we're going to talk about is garbage collection. Essentially, when you run computers, when you run their programs, they use memory, right? Because it has whenever it's running, it does functions, and these functions take in inputs and create outputs, and both these inputs, outputs, and the functions themselves have to be stored. And so during the course of a program, it might generate it might use up lots of memory. Garbage collector is this function that's automatically implemented in Java, where it automatically takes any unusable data or any data that you're just finished with, and it will automatically dispose of them. And languages like C, at least until very recently, you have to manually close and manually dispose of all your data. Otherwise, you would accidentally cause memory leaks, which is essentially when you have information you don't need anymore, but you didn't get rid of it. So it just keeps taking up space in your computer and just not contributing anything of value. Java is, again, really convenient, and it implements this garbage collector automatically for pretty much most of the programs, except for like a few cases. So you don't have to worry about these memory leaks happening. You don't have to consistently be paranoid about whether or not you actually close the file or function. So essentially, garbage collectors prevent memory leaks, and it's pretty good. If you don't have any space for memory, then you can't do anything. You can brick your computer entirely if your memory gets filled up, and you have to restart it. And finally, the third concept, the third main thing about Java that you might want to learn is that it's platform independent, where essentially Java doesn't need to be translated to work on platforms. It can operate regardless of the platform you're on. Java will work the same no matter what kind of device you use, unless you specifically invent a device that doesn't work with Java. But generally speaking, any platform independent languages work on any platform. It doesn't matter to it. It's independent of the platform. You have platform dependent languages that only work on specific things. And while these languages do tend to be really fast and convenient on the platforms they're designed on, since they were designed for that platform, they are really hard. Any programs you write in that language, you can't move to another platform. You'd have to rewrite it entirely in a different language. So Java here essentially makes it easy to migrate and easy to move around. So you don't have to worry about having to, if you move to a new device, you don't have to worry about too much about having to rewrite your Java programs. It doesn't matter what platform it's on. And finally, the last, okay, so another basic concept that you want to know is the difference between high-level and low-level programming languages. Or essentially, as I'm sure you realize, computers don't speak English or really any other talking language. Computers primarily communicate in binary, right? Zeros and ones. However, in order to write programs, we have to somehow convert our own human language into the computer's language. And so essentially, well, in order to do this, we use programming languages like Java or Python. And essentially, we can use our human words to write things in this programming language, and they will then translate it into binary. And so, but however, there are different levels of these languages. High-level languages is essentially languages that are closer to the computer's own language than our own. So essentially, languages like C or Java are high-level languages. And wait, sorry, I messed up. Sorry, high-level languages are languages that are closer to like human stuff. So like it's easier to read and understand. So stuff like Java, for example, can be considered a high-level language because it takes a few more repetitions to reach machine language and then the hardware. So high-level languages are essentially, like you can think of it like a pyramid almost. You have the hardware, which is like your actual motherboard and stuff. And then you have the machine language. And you have low-level languages. And then you have high-level languages. Essentially, high-level languages are easier for us to read and code in, but they take more steps to reach that hardware. Whereas low-level languages, while they're really, depending on like the level of lowness, it can be really hard to read. And if your language is low enough, if the language, its type is low enough, then it can be almost indistinguishable from the actual machine code. So yeah, these four concepts are pretty important to understanding how programming languages work. So these three are probably something you will have to remember. Object-oriented programming is program oriented around objects or data storage and data collection. Garbage collectors are essentially programs in Java that automatically prevent memory leaks for you by deleting already used data. Platform independent means that it's easy to move your programs around. Java doesn't care about what platform you're using. It only cares about like as if you have the necessary environment to run it in. And high level and low level languages essentially represent the amount of how far away they are from the actual machine code itself, and is often one reason why some languages are considered fast than others. And it's also why the speed of a language can often indirectly correlate with its readability. I'm going to erase this real quick. So if you want it, you'll better write it down real quick. I'll give you about 20 seconds. All right. If you didn't get it, I have a Google Classroom that I set that you can look at it later. I'll give you the link to it at the end of this class. Finally, let's talk about some other basic knowledge you'll have to know before coding. Specifically, errors, bugs, and glitches. When programming, it's basically inevitable that you will encounter an error at some point. It's practically like a rite of passage almost. And so the three categories we classify errors in is syntax, compile, and logic. Essentially, these three errors represent when the error happens. In programming, especially in programming, what the root process usually goes, you write down the code, and then when you tell the code to run itself, the computer does three specific steps. The first step, it does is it kind of just reads through the code real quick and checks for essentially grammatical errors, which is what syntax is. if, for example, let's say you have a program and it has a function that's just called do addition, right? And do addition is just simply supposed to add two numbers. But if in your code you write like the name of like a number wrong, or if you write like the addition sign wrong, then it will return a syntax error. Or essentially, if you, for example, if the function is called do addition, but when you write it again, you accidentally write it again, but you misspell it like without this last D, it'll return a syntax error because it doesn't recognize what this do add is, what this new function is supposed to do. And we clean this up a bit. So if you have a function do add, and then, but when you try to like use it again and you misspell it, this will produce a syntax error because the program doesn't recognize it. It says it basically says, I don't know what do add does. You made a function called this, but this is not the same. Essentially, syntax errors are just grammatical errors in code. You write something wrong, the program, when it's reading through it first, will catch it and output this syntax error. And this is the first error the program always catches, since it's happening on its first kind of check through. The second error comes during compilation phase. This phase happens after it does its kind of grammar check, and then it thinks, okay, so this program looks like it's going to work. We're going to compile it. What compiling does is essentially, this is when the language moves from high or low level all the way down to machine code. So this is essentially the de-leveling of the language into something we understand to something the computer understands. However, during this step, it can also return error if you wrote something incorrect in your program. For example, a compile error can occur through things like dividing by 0. In syntax, this will not return a 0. If you write 5 divided by 0 equals what? The program will read it first and thinks that's not grammatically incorrect. This is grammatically correct. You can write, because the program just sees a number and then just sees an operator or division, or like a division sign, and then it sees another number. And it goes, yeah, okay, that works. That makes perfect sense, but I know. But when you actually compile it, where the program essentially starts decoding it into machine level language, and this is where it actually starts running. And so it's going to go through all types of programs, and when it reaches this part, it's going to return a compile error because you can't divide by 0. That's not possible. So compile errors are essentially any errors that occur that aren't a result of grammatical errors, and they're simply just things the computer isn't designed to handle. It's sort of like dividing by 0. Logic errors, meanwhile, are exactly what it sounds like. This is essentially when the program works fine, but it doesn't return the correct output. For example, if you wrote a program called do addition, and when you give it two numbers, 3 and 5, instead of returning 5 plus 3, 8, it returns 7. That would be an example of a logic error, where somehow in your program, you wrote some code that led to an incorrect logic. One thing you have to understand about computers is that they always do exactly what you tell them to do, not what you want them to do. Unlike with like humans, for example, we can get your intention across. The computer doesn't understand intention. So it will take exactly what you say and then write it down. So for like in the do addition example earlier, if you like added, like, if you like, for example, on the divide by 0 case, if you decide to just write a +1 for any case to kind of just make sure that it never equals 0, this could lead to a logic error where all your other outputs are now wrong because you're trying to avoid that 0 case. Essentially, logic error is simply when you write a program and your logic is incorrect. Somewhere you made an incorrect step. So these are the 3 types of errors that occur in computers, and they can all be classified into one of these 3. Syntax is the grammatical error. What happens when you just write something wrong, write something the computer doesn't recognize. Compile happens when there's no grammatical errors, but you wrote something that can't work anyway, like the 5 divided by 0 case, where at its most basic level, it's just a number, an operator, a number. But because one of the numbers is 0 and it's division, it returns a compilation error because that doesn't work. And logic error is simply the program technically works fine, but it's doing something you didn't want to do. It's doing This usually occurs because you didn't explain to the computer perfectly what is going on. So these are the three most, these are the three types of errors that happen. I'm going to erase this now. All right. Now let's actually look at what the code actually looks like. I'm going to, specific in the IntelliJ IDE, in order to actually create code, you need somewhere to write it. And so what you need to do is you find the source folder right here, this blue folder right here, click new, and then you click new Java class. I'll send like a video in the group. I'll put a video in group class so you can actually go look at it later. For right now, I just really want to focus on you guys like seeing the code itself. So you don't have to actually do it right now. I'll send you, I'll explain it later, like in more detail later. But right now, I just want you guys to look at the actual typing. So we're just going to give it a random name. So you might see here that it automatically created this, this little text here. This from Java, this text is essentially just saying, this is the name of your new program. In order to make the program runnable, you have to add this spot here. And what this is saying is essentially saying is this is a main program. This is the program that you were going to start with. Any program that doesn't have this spot is essentially, you can think of it as a side program. It won't ever run by itself. Instead, you have to use a main program to access a side program. Essentially, this entire thing is called skeleton code, or essentially like a skeleton. This is the base of pretty much any program you're ever going to make. And without it, you can't code anything at all. Like without a skeleton, you can't move. So this is pretty important. The only, this entire thing never changes. The only thing that can change will be this title here. Depending on whatever you name the class, then this might change. However, this must match the actual class name itself. If, for example, I try to rename it like this return error because, right, what I wrote here is I'm saying the program ASD is in the file tutorial, and the computer is expecting the program tutorial to be in the file tutorial. So for the so right now, so essentially this has to be the same. Because the computer is expecting the file tutorial to have the program tutorial. Now, so the first thing we're going to learn is how to actually create output. To do that in IDE, we're going to use a statement called print. We're going to tell the system to do an output of the print variety. So here is what is called a function, and specifically this, and right now you don't even know this function specifically. Print, what print does is if you give it any kind of data, like for example, a number, like a word, right? We take quotation marks to signify it's a word. And then if we run it, it will output the word down here in the output box. Or this is essentially how the IDE will translate your outputs for you. And the other print statement that you will also have to learn is print n. This works exactly the same way, except this one adds, instead this one adds an extra line. What this one does, the difference between print and print line is that print will simply put down the word or whatever thing you put in this little box here. But with print line, it adds, it essentially presses the enter button on your keyboard. And so any other print statements, any other output you put after it will be on the next line. What I mean by that is if you did multiple print statements, they will all appear on the same line. Word 2. But if you put print line, it moves the cursor. It presses the enter button. See, now they're on separate lines because of this print line I added. You can also manually add enter with escape sequences. And essentially escape sequences are just kind of shorthand for writing different buttons that you don't really want to write out loud. Like /n, for example, does the exact same thing this ln does. It adds an extra space, sorry, not a space, adds an extra enter at the end. Or /b will add a backspace, /t will add a tab. Escape sequences are pretty useful to know. And while you can just kind of replace them with just like lots of spacebar tabs, they're still pretty useful to use. So essentially right now we're talking about, so these are basically different types of outputs you can use, and these will be the most important ones. Well, there are different ways we can make output come out, but for right now, these are the ones we're going to have to know. And these are the ways we're going to demonstrate to the user, demonstrate to the user that the program is working and that the program is capable of shooting at this output. So in order to actually use these print statements, though, you might notice that we need this data. We need to put something in this parenthesis here, these two parentheses, so that it knows what to output. You can't put nothing in there, because if you put nothing there, then it thinks that the thing you want to print out is just nothing. So it'll just print out nothing, because nothing is still technically data type. More specifically, in order to actually put things in here, we'll have to learn how to create data, and then what types of data there are and what types of data are legal. The most commonly used types of data, and you really won't see much outside of these. The main data, okay, so the main data we're going to be using is essentially integers, which are numbers, strings, which are essentially words, and characters, which is essentially just characters. Now in Java, you can't just simply type like integer a, like integer 3, right? If you want to actually store, if you want to actually use the data, you have to be able to signify what it is. For example, like you might have noticed earlier that I use these quotation marks. These quotation marks signify the type of data that the print statement is going to be using. If I didn't put the quotation marks there, then the Java would be mad at me because it doesn't know what this is. This word, to Java, what I would type here could mean anything, but by adding quotation marks, it now recognizes that this data type is supposed to be a type string, and strings are essentially just words. Another way to kind of see this is the reason just typing normal word doesn't work is because it can be the name of something else. Like for example, if this program was named Word, for example, then the computer will also be confused because then it doesn't know whether you're typing in a string word or the actual you want it to output the entire program itself. However, simply typing integers by itself does work because there is no way to define an integer there's no way to there's no nuance to them. While integers can still be defined differently, there's no way to make this 3 mean anything other than 3, which is why Java thinks it's okay. But it's possible the word means something else. So yeah, in order to demonstrate this, we're going to actually show how word can mean something else, but 3 can't. So one other way of kind of putting data isn't straight up putting the data here. We can put it a placeholder. And what by that mean is we're going to create a placeholder. So for example, if I want to create a placeholder that is a string type, I would have to write the word string. So basically saying the title is string, like how you would say Mr. or Mrs. before someone's name. And you put the actual placeholder name. So we can just name this string name. So essentially, right now, what this is saying, essentially saying the title and then the actual name, like how you say Mr. Person or like Mrs. Person. Then after that, we have to put an equal sign after it to kind of say, because this is a placeholder, right? So in other words, it's going to take the place of something. And so this equal sign tells the program that this placeholder, this string name, is taking the place of or has the value of whatever you can put after it. In this case, we're just going to put word, and then we add a semicolon. So this right here is one of the more fundamental parts of object-oriented programming. Or essentially, we created an object that has a type. Its type is string, and as its name is string name. This object is essentially a bucket, and this bucket or this placeholder contains and points to this string word. So now by typing string name into here, you can see that it's no longer red. If you didn't have this here, it would still be red because it doesn't know whether or not this is supposed to be a string or if it might be some other object you created. But by defining it here, it works. However, you cannot do the same with numbers. You cannot write, for example, string 3 equals something because the Java language specifically recognizes 3. Because you can't name something 3 because otherwise it would create the same ambiguity as before. However, it is legal to make strings. It is legal to put numbers in strings. And the reason is because when you put it inside these quotation marks, this 3 doesn't actually mean 3 anymore. It simply just means a character, a letter that looks like 3. But it won't actually react in the same way as you might do a normal 3. These specific objects that hold data, a single type of data, we call them variables in this language. And the reason we call them that is because this object can hold different types of data, or in other words, it can vary. And it's also basically essentially also referring to math, where in algebra and other math courses, you have variables, for example, like the variable x and x and y, and they can mean different things. For example, you can create a variable named x and have it also mean something. Like just like in algebra, the variable x can mean anything. It's essentially a variable. Now, strings, of course, are not the only type of variable you can make. Like I said earlier, we also have integers, which in Java, we simply write the word int instead as shorthand. So this might be a more traditional way of looking at it. The variable x, like we've all seen in our math class before, right now stands in for a letter. I'm sorry, a number. And y, for example, can stand for another number. Note that, however, that this type must match the data you're holding. You cannot match a type with an incorrect data, as you can see here. This int x doesn't work anymore because this int tells us x is supposed to stand for an integer. Essentially, this object x is only ever supposed to point to or hold a number. It's not designed to hold things that are not numbers. So it returns an error here. And same thing for y, and also same thing for the string up here. If you replace it with a number, it stops working because the program is telling you that it's not just that this specific piece, this variable here, isn't designed to hold that. There are also other variables and their containers. We have doubles, which are essentially the same thing as ints, but are only but they can hold decimal numbers instead. Integers, as you might guess from the name, can only hold integers. So negative numbers are fine, zeros are fine, but anything with decimals no longer works because that's simply because it's defined as integer, it only holds integers. And doubles essentially is just a Java name for any digit with decimals in it. But doubles are capable of holding the numbers without the decimal because these are still real numbers. These are still rational numbers. They're not like, because they're one, but when you actually run it, it will just interpret the 3 as 2.0. So any integer number puts in will simply interpret it as a 0.0 of that same number. And there are many others, but these 3 plus character, which has its own unique signification. These 3 are really the only ones you should know for most of it. Character in particular is special in that it's essentially a string, but since it's a character, it holds you can only hold one letter. You can't put more. characters are only ever one specific character. It's not characters after all. So essentially, now that we know how to store data, we can then use it. Then we can use these print statements to then output the data. Like for example, we can output X. We can then output a Y. And if we really wanted to, we can also use these variables to actually do math. X plus Y, for example. If you run it, it would return 7 because, like I said before, these are placeholders. They're pointing to things, or you can think of them as buckets. They contain it. And so when you do X plus Y, it's not trying to add the names, but rather whatever they're pointing to. Or in this case, is 3 and 4. So lastly, the last important step of this process in programming is inputs, where we know how to store data and we know how to output it, but now we actually need to be able to change this data based on inputs. So here we're going to essentially allow the program to collect data by creating a scanner, which essentially just scans a text box for any text. And once the user puts a text, it'll take in that text and you can do stuff with it. The creating of a scanner is pretty similar to creating a normal variable, but it's not exactly a variable. It's more specifically an object. Variables are essentially types of objects, while objects are not all objects are variables essentially. Essentially, variables are some objects that can also be classified into it. A scanner, the reason scanner isn't exactly a variable is a bit nuanced, so we're not really going to touch into that right now. But the process works really similar. You say the type, and then you say its name, but because it's an object and not like the primitive variable discussed earlier, you have to put a new at the end. So what this line of code is essentially saying is you can compare to other ones. It's saying we have a scanner type object that's called SC, and this object is equal to, or in other words, this object is now holding a new scanner of system.in. And what this is, and what system.in means is essentially just input from the system, or is essentially just input from this IDE. Or it's so that, as you can see, the format is pretty similar. The scanner, the object SC of type scanner holds a new scanner object that takes in inputs from system.in. In order to actually use SC, however, you have to get data from this system.in. And the way we do that is by by using SC to simply tell it output whatever the user inputs. So firstly, we have to store this data somewhere. We're going to create a string. And this store data is we're going to set it equal to whatever SC outputs. So here what we're doing is something we're actually so we're taking whatever the next input is in scanner and putting it in store data. This is also an early introduction to methods, which we'll have to talk about a bit later. But essentially what you need to know is that SC is capable of returning whatever the next input is. And then essentially, so in other words, and so instead of actually putting in sc.next inside store data, what we're actually doing is we're taking whatever sc.next is pointing to, and we're going to take that and put it in store data. Essentially, this is as if you created this. Essentially, this is the same thing as creating this int x equals 3 and creating a new int called y and setting it equal to x. Y is not equal to an actual x, but rather y is instead equal to whatever x is pointing at. So y is a stored value of 3 rather than like x itself. Here, the scanner object here, we store data is not actually equal to the scanner itself, but rather whatever scanner.next is pointing at. And then in order to actually show it off, in order to like recognize actually repeat, we'll have to then output this stored data. So if you run the program, which you can do by clicking run, or the run button in the corner. You can see that it hasn't output anything yet. And it's because the program is waiting for the user to do something about the step. So if you type in something like hello, you can see here that it outputs in hello, because the string stored data stores whatever the scanner received as an input, which happened to be hello. And then it then outputted that data in its next statement. So then this 3 steps is essentially the core of any good program. Some way to receive user input, so that way you can vary your output based on whatever it is. Some way to store that data, and then so that we can change it and manipulate it if you need to. And then some way to return or output that data. And yeah. Of course, there's the steps we're going to be focusing on in our next couple of classes, and today as well, is going to be focused very much on this step. Java is all about the storing data and manipulation, and so most of your programming, most of its logic stuff is going to come between the gathering of data and the actual outputting of data, because the input of data should be relatively simple. All you have to do is simply just kind of grab whatever the user is giving you and then store it into something. And an output should be fairly simple. Once you have what you want to output, all you have to do is simply write a print statement. However, it's the process of changing the user data into something you actually want to output is usually going to be the bulk of your program. And so, yeah, as a sense, so that's going to be like the most important steps of print. So for starters, we're going to talk about basic stuff like how mathematics work in programming. In Java specifically, it works more or less what you accept, more or less like you would think it would. You can create by creating different integers. You can perform basic math operations. The basic math operators all work. When you put 2 operators together, 2 different ints together, or any 2 of the number variables, you can use the plus sign, the minus sign, multiple sign, divide sign, and they all do pretty much what you expect. One thing to note, however, is if you are using ints, they're specifically only integers, right? So that does wonky things with division, because if you do 2 integers divided by each other, most of the time that would give you a decimal number. But because not only are these 2 numbers integers, but because we're also trying to store it in an integer here, this divide sign will only ever give you the integer form of whatever number you get. So in the case of 3 divided by 4, it will put a 0 in Z rather than 0.75, because the integer type is not built to store any decimals. So any decimals that are present in the number will simply get rounded off. And the program always rounds down because it simply removes it. It doesn't actually add or subtract it to it. It's just straight up removes anything after the decimal point. So yeah, if you want to keep the decimals, you'll have to use the double I talked about earlier. While technically you don't need both X and Y to be doubles, you can just have one of them be double. And then make sure your storage variable is also a double. And this would give you a number with decimal in it, but in practice, it's usually a good idea to make all of them doubles if you are trying to go for the, you're trying to get decimal numbers, because that way you don't lose any data when you convert things. If you had int X up here, then you could possibly lose data as you try to convert as like the X to the double and then back again. So yeah, those are the basic math operators and the basic I expect. When you put 2 numbers and you put an operator between them, the program will run through it. It will look at those 2 numbers, and then it will do whatever you tell it to do, and then it will combine that data or combine that data together, do a single number. And regarding order of operations, the computer follows the basic rules: parentheses first, exponents, and then it'll do everything else from left to right, starting with it'll do multiplication, division left to right, and then addition left to right. You can always change this order by simply just adding a ton of parentheses as well. Now, these aren't the only operations. Computer has a ton of other ones other than just these basic 4. The other important ones that you will probably want to remember is the modulus operator. And so this is essentially this one, right? When you use a percent sign instead of any of the other ones, what this does is essentially instead of returning another number, it returns the remainder when you divide them. Or essentially, it divides the number until it can very similar to division, but instead of returning the actual result, it returns whatever is left. So in case of 3 divided by 4, it would return 3 because when you do that, that's what if you when you do 3 by 4 and you don't divide it down to the decimal points, the number that's left is simply 3. Or if you had 7 and 4, 7 modulus 4 would return 3 because when you divide 7 by 4 and you only divide up to the integer spot, that gives you 1 and then a remainder of 3. These 5 are the most important mathematical operators to have to know. As for exponents, there's no really true exponent command in Java because some keyboards either don't have, because specifically this sign, the exponent sign here doesn't, is actually used for different meaning than, it has a different meaning in Java than expect. If you want to do exponents and stuff, you have to either create your own, you have to either create a function that mimics the use of exponents, or you'll have to call a different one of Java's own methods that it will automatically calculate the exponent for you. So right now, the most important stuff is simply this. It's simply the basic 4 operations plus the modulus ones. Because this class is going to be there's some homework that I do want you guys to do later. That's basically essentially going to focus on the usage of these operators, the practicing inputs and outputs, as well as the various kind of miscellaneous knowledge we also learned about. So I'm going to actually put out the Google Classroom link right now. And you don't have to do it, but it's I do think it could be good practice. There are the 5 questions on it that you can work on later at home, so that way you can kind of review what you know. I'll put some more on there as time goes on. But yeah, so essentially, now that let's go through like an interactive exercise about inputs, outputs, and how to manipulate data. So firstly, let me get rid of all this. Let's say you wanted to make a program that, like I said earlier, does addition, where it takes in, and this program is going to take an input of 2 numbers, and then it's going to add them together. How would you think you would do that? You can put in the chat or you can speak it out loud. Anything's fine. And assuming you already had this basic code outside. How do you think you would take in 2 numbers, and how do you think you would get them to add together and then output it? Right, so the first answer I got simply said something along the lines of, you use the SUsed scanner, like I said before, use its sc.next to get 2 inputs by repeating it twice. Then you simply store that data. Whoops, in 2 different objects. Actually, these should be You simply use scanner to receive 2 numbers from the console down here. Yeah, when you use, and then you simply can create a 3rd one that is simply just the first 2 add together. And then you can simply write it out in the print statement down there. Yeah, that looks right. At least the stuff I've seen in the chat so far looks pretty right. Essentially, I've seen, as long as you get the numbers here, you can just simply add them together and then output it out. So as you can see here, if we run it, we can put in our first number, our second number, and it'll give us the correct output. Now, you might notice that I put this sc.next in here instead of next. That's because, like I said earlier, type specific variables can only hold their type. And sc.next specifically is supposed to return whatever this is as a string. Remember, you can put numbers inside of strings and it works just fine because the program classifies them as words instead of the actual number itself. But this means that when you do create input, you have to make sure that your input matches whatever like the program is expecting. So in this case, because we want to use two numbers, we had to specifically tell the scanner to look for numbers, or in this case, the next integer it sees, instead of just simply the next string it sees. All right. How would you, I want to know, so here's another question you guys want to work on. How would you tell the program to take in someone's name so that it can receive someone's name as input, and then it should output the name followed by hello? How do you think we would do that? So specifically in this case, what you want to do is, first off, you need somewhere to store their name. So we would create the string object and we can call it their name, we call it name, and it needs to take in the input. So yeah, the answers in chat look pretty right. Okay, yeah, so the answers you have sent me look pretty, do look right. At least the ones I've got. Yeah, so essentially what you want to do is, in order to get the person's name, we use this scanner object, which is connected to the keyboard. We take this and then we take this scanner object, whose name is SC, tell it to, and then we simply just tell it to give us the next input from the keyboard. And this way we can store it inside this name object. In order to print out the name and hello, there are two methods to this. One way is to simply just do a print statement twice. You probably have to add a space here, so you can separate the two words. So this works pretty well. Remember, because this is a simple print statement, it doesn't add an enter. Only the print line does. So this will put name and hello on the same line. So for example, my name is Daniel. I will take in the name. So the program will create a scanner. The program will then put the scanner's next string into the name object. It will print out the name and then it'll print out hello. You need to get really good at being able to kind of, you'll be able to need to get really good at kind of reading through the program. If you want to create a good program and you want to check the bugs, you have to be able to kind of go down through the program and simulate its running process. In this case, specifically, when you start it, it starts from this main and moves down each line and it sees, okay, so it sees scanner and it says, okay, so we're creating a scanner object here. And it says, okay, we're going to use this create a scanner object to find a string to put in this name object, and we'll simply do this output. Also, if you wanted to make this message more grammatically correct, you could, in fact, reverse it around and simply also reverse it around. So, however, there is a second way to actually do this that I haven't actually told you yet. And this way is by using the mathematical operators we talked about earlier. They actually, in fact, work with strings. And not all programs do this. Some programs will just return an error if you try to use math with strings. But the way Java handles trying to use strings math is that it simply takes the two words, whatever, and just joins them together. In this case, if we had a string hello, and you just, it's hello. Instead of printing out hello and then printing out name, what we could do is actually take the first string and add it to the second string. And what we'll do here is straight up combine the two strings together. Now you want to make sure, now remember, it doesn't add space between strings, it straight up adds them together. So if you want space and stuff, you will have to manually add yourself, either by adding a space in the string, or you could also manually add a space like this using the addition operators. All right, so that's about how long we have this class. If you have any questions, you can stay at the end of class and I can help walk through these things. I saw a few of them in the chat, so you can stay behind. I can help walk through that. And you can also look at the Google Classroom to practice a bit more of the concepts you learned, the input, the data manipulation, and then outputs. In the next class, we're going to learn more ways of gathering data and manipulating them. Specifically, the subject we're going to learn, if you want to study ahead of class, are methods and Booleans, which are essentially other data types like integers or chars, but instead of holding your normal like word keyboard type, instead of holding a normal keyboard typed character like a number or a letter, they hold true false values. And then we'll also learn about functions. So these are the three things we're going to focus on in our next class. All right. There's going to be a total of about 10. There's 5 assignments on the Google Classroom. We're going to add about 5 more by the end of today. So there's 10 you can do for practice. These are going to work on next class, and I will also share the recording with you guys once it's like set up and everything. I did record it and it is available. I just need to like save it. So if you have any questions, you can stay after class. I did see them from the chat, so you're welcome to stay. But otherwise, you're good to go. See y'all.